Okay, so yesterday we went over slope from a graph and slope from an equation. What is it that we use when we find slope from a graph? What is that little saying we use? When we're finding slope from a graph, what do we use? Rise over run. Okay? And from an equation, we just need to know the slope-intercept form of the equation so we can recognize the slope and the y-intercept, all right? Okay, so we're going to go to a table and to 2 points, all right? And I think we're going to do 2 points first, and then we'll come back and look at a table. So let's look at 2 points, all right? First off, let's look at our mathematics chart, which you should have pretty handy dandy. And under linear equations, okay, we've gone over this slope-intercept form, okay. Now we're going to be looking at slope of a line. And slope of a line, mine looks really tacky here. It's not coming in clear, okay. But slope of a line, because, I don't have my glasses on, so I can see here, but I can't see over there, just so you know, okay. It says y2, it says slope, which is m, is equal to y2 minus y1 over x2 minus x1. All right, so slope is equal to this little formula. So when you have 2 points, you label your x and your y coordinates, okay? Find the change in y and then find the change in x using the slope formula y2 minus y1 over x2 minus x1. All right, and I'm going to show you how I want you to do this. If you do this every time, you should be just fine. All right, so I've got 2 coordinate points, don't I? Each coordinate point has an x and a y value, don't they? Now, it doesn't matter what order I do them in. I could make this my x1 and this my x2. I could make this my x2 and this one my x1. Generally, when I teach it, I just teach. This is x1, this is x2. But it wouldn't matter as long as when you make x1 here, this has to be y1. When you make this x2, this has to be y2. If I made this x2, then this would have to be y2. You've got to keep the pairs together, okay? So what I kind of do here is an x1, y1, x2, y2. If it's easier to do your 2's first because that's what you write on your equation first, then go right ahead and do that. It doesn't matter as long as you keep the pairs together. So it says I've got y2, which my value is what? 17. And then I'm going to put this subtract sign before I even look at my y1 because that subtract sign is there regardless. And my y1 is 5 over my x2, which is 4, subtract sign, what my x1 is, which is 0. Okay? So now I've got 17, take away. You can't do this as one whole thing, all right? You've got to do each part, even when you're in a calculator. You can't put 17 minus 5 divided by 4 minus 0. It won't work, okay? You got to do this. 17 minus 5 is what? 12. And 4 minus 0 is? 4. And then you always want to simplify it and leave it as a fraction, which all of you, even if it turned into a decimal in your calculator, would remember how to change that back to a fraction. 12 divided by 4 is what? 3. Okay, and 3 over 1 is a fraction. So your rise is 3 and your run is 1. Okay? Now, the reason that it doesn't work when you put it all in at the same time as a calculator, think about PEMDAS. If I was to put 17 take away 5 divided by 4 take away 0, what is that calculator going to do first? Because that calculator follows PEMDAS. It's going to divide. okay? And remember, we needed to subtract both, then we can divide. It still won't work out for you. So just go ahead and do them both individually and find your answer, okay? All right, so here our slope is 3, our rise is 3, our run is 1. So that would be something like I'd be going up 1, 2, 3, and over 1, okay? My rate of change is 3 for 1, all right? Let's try the next one. I've got x1, y1, x2, y2. I've got to follow y2. All right, y2 is negative 6, subtract. Now I'm going to look at y1. It's negative 10. So do you see why I say build that habit to put that subtract sign before you even bother looking at your second digit, okay? And that is all over x2, which is 0, subtract x1, which is negative 12. Integers will never go away, okay? They're always going to be around. They'll always be there for you. So if you still are unsure, I would be playing on, there's got to be some apps out there, some games that challenge you with integers, and I would find them. I'd work on them, especially the subtraction. Okay, and I would find those games where they don't do 5 plus a negative 5. I'd find the ones that do 5 minus a negative 5. Okay, because you're never going to see it as 5 plus a negative 5 anymore, or minus. You know what I mean? You want to see that 5 minus 5. You want to see it as that. Okay, all right, negative 5 minus 5. Because then you're going to get used to the habit of that's combining two like terms. Negative 5 minus 5 is actually negative 10. Okay? All right? Here we go. And yeah, eventually I'll let you play with the calculators with this. But for now, I need you to get those skills built up. All right? So what happens here? This changes to a what? What happens when these two signs are together? It changes to a positive, doesn't it? So I have a positive 10 and a negative 6. That's how I look at this. All right? And I take the larger number 10, subtract the smaller number 6, and keep the sign of the larger number. So I end up with a positive 4, don't I? Okay? Here I've got a positive 12, and I've got a 0. Well, what's the difference between 12 and 0? It's 12. So 4 twelfths gives me what when I simplify it? 1/3. 4 goes into itself once. 4 goes into 12 3 times. Okay? So here my rise is 1 and my slope is 3. Now, the difference of that, which line do you think is going to be steeper? Everybody agrees the first one? If I'm going up 1, 2, 3, and over 1, my line is going to look something, and I know this is just a really terrible rendition of it, but it's going to look like this. If I'm going up 1 and over 3, my line is going to look something like this, which is less steep. So since your rise is greater than your run, your line is steeper, okay? Remember this, if your slope is greater than 1, you're going to have a steeper line. If your slope is less than 1, you're going to have a less steep line, okay? All right. Here we go. X1, Y1, X2, Y2, and I've got, let's see, Y2, which is 11, subtract Y1, which is 7, and I've got X2, which is negative 5, subtract X1, which is 0, and I end up with 11 take away 7, which is what? 4, and negative 5 subtract 0 is, and you can write this, I think I went over this yesterday, it could be the middle, the top, the bottom, it doesn't matter, it all means the same thing, okay? And that can't be simplified any. 4 and 5 have nothing in common, all right? So this time you would rise 4 and you would run 5. See how it's less than 1? It would be less steep, okay? All right, because look at your run is further, so you're going more horizontal than you are vertical. All right, so that's all there is from 2 points. That's basically the whole thing about 2 points. So let's look at from a table. Okay. All right, from a table, you find the constant rate of change of the x values and the y values. Write the change as y over x. Okay. Now, there's a couple of ways you can do this. I would suggest that you do it just like 2 points at first. Okay. Even if they're not labeled as x's and y's, any table that you ever see, I mean, if you see a table of values like this, and it says apples and price, let's say, okay, any table that you see like this, the left is always going to be your x values unless they state differently. And I'm telling you, for you guys, 8th grade algebra, I've never seen it stated differently, okay? The left is always your x. The y is always on your right, all right? So if you have this situation, now if you have a table that is like this, where is your x? X is always on top, y is always on the bottom, okay? It just always is, even if it's stating it's you know, gum and, I don't know, people, okay? It's always going to be x on top, y on the bottom. So, to find your slope from a table, I suggest this. You take 2 in the middle, okay? You've got to remember, especially a table that's horizontal, these are your y values. So this is my y1, this is my y2, this is my x1, this is my x2. What was our formula? y2 minus y1 over x2 minus x1. You're going to be able to say that in your sleep, okay? So I've got y2, which is 4, subtract y1, which is 2, over x2, which is 1, subtract x1, which is 0. 4 minus 2 is 2. 1 minus 0 is 1. And I've got a slope of 2, don't I? Okay, and I would simplify that to 2, okay? But you've got a slope of 2. So in a table, you can do it just like from 2 points because a table has points, okay? The other way you can do this is the change in y over the change in x. And essentially, when we're doing that formula up there, we're saying the change in my y values over the change in my x values. And by the way, that triangle means change in, okay? So the change in y over the change in x. What I could do is pick these 2 right here. And you kind of want to do the ones in the middle, okay? And I can just, when I get better, or when I have that calculator available, it's much easier to do. I would highly suggest that you don't do this, and I'll remind you of this later. But I could do 8 subtract 16, and I would have negative 8, wouldn't I? Okay? I'd put that on top. Those are my change in y. I could do 12 subtract 6, and I have what? Positive 6. I could put that. Now I simplify that. 2 goes into 8 4 times. 2 goes into 6 3 times. I end up with a negative 4/3. Okay? I would highly, highly, highly suggest that you use the formula until you get really good, or you've got that calculator in your hand to do the actual equation of the math integers for you. Okay? But it just because it's too easy to make mistakes when you do it that way. All right? I will teach you in 8th grade this, and then I'll show you this, and then in 8th grade I'll probably teach you how to do it in the calculator like this. All right? But in algebra for now, since you guys haven't had this 8th grade stuff, I think it's better to practice this first, and I'm trying to build your skills. That's why I haven't handed you those calculators yet, okay? You really need to have those skills down, all right? And that's why you haven't gotten them, okay? So we're building those integer skills. We've got to be good at them, all right? So, and I'll just quickly go over this. For a word problem, we're not going to do any practice of this. You're looking for keywords like each, every, per. Those are your slope. Okay, you're looking for those things. This is your rate of change. Jack has 5 toy trains. He plans to buy 2 new ones each month. So what that's telling me is that I'm getting 2 each month. That each is indicating multiplication. Each month is my variable. I'm getting 2 new ones. Do you see how that works? Okay. So my slope here is 2. My rate of change is 2. Okay. The initial fee is always your y-intercept. Do you guys know that? Have you been taught that? Okay. So a y-intercept is a starting point for a problem situation on the graph. Okay. And if you have a graph and you have a real life problem situation, the y-intercept is the initial starting point on that graph. If it is at 0, it means your y-intercept is 0. If your starting point is like this one, an initial fee to have a website set up using a server is $48. So on my graph, I would have 48 is the starting point on my graph, and it costs $44 per month. So in other words, I would have a graph that looked like y equals 44 per month plus an initial fee of 48. And that's what your equation should look like. We probably need to do that. I wasn't planning on doing that before we got started with algebra, but I think we need to do that. We need to write equations and understand the equations a little better. So we'll probably start that on Monday. Because if you guys don't know how to write an equation from a word problem, from a graph, I'm guessing no? Nobody could do that? Yes or no? Have you been taught that? Okay. So we need to we need to be able to write an equation from a graph, from a word problem. We need that skill so we understand the parts much better than we probably do. And I'll go back and I'll bring that up on Monday. We'll probably practice that Monday, Tuesday, maybe, before we go on. I'm sorry, like I said, this is a learning curve for me, just like it is for you, about what I need to make sure you understand before we get there, okay? And I will find some tools and we'll go over this the next couple of days, all right? Because I want you as prepared as you can possibly be, okay? All right, so we'll hit this because you would get this in 8th grade. All right, I thought 7th grade touched it, but probably not. All right, so I'm going to give you your work for today. I'm not going to go over that anymore because we'll go